Yep. Hi, everyone. My name is Carlos. And as Sebastian said, I'm working at the FKI as a researcher, and I'm also doing my PhD under him, working on this topic of speaker anonymization. And my aim today is to be more broad about the two different topics that are relevant for speaker anonymization. Hopefully, after this lecture, you can read papers in this field and understand them more easily. And I'm very happy about any questions that you may have along the way. I'm not used to talking for so long, so any interruption is very welcome. So my idea is to tackle the issue in 5 different sections, starting with privacy in general, like what is the importance and the meaning of privacy, then diving into how we apply privacy concepts to speech, how do we evaluate them, both from a perspective of privacy and a perspective of utility, which we'll see is an important trade-off in this field. And finally, if we have time, I would like to cover the topic that I'm most interested right now within this field, which is how prosody relates to speaker anonymization. So to start off, the definition of privacy is a bit vague. It's really hard to define. The first work on the topic of privacy comes from 1890 from 2 American researchers, where they said that privacy is the right to be let alone. And it is viewed as the foundation of individual freedom. Like, for example, here in this image, you see the height of 3 different persons. And imagine a database where the only thing you know is whether they are taller than 170 centimeters or not. In this case, this information is sensitive and it breaches the privacy of the blue person, because if you know this information about these 3 persons, you can already infer which data relates to the blue person. So you could say that this data is not anonymized correctly. It's not privacy preserving. So what this implies is that how characteristic certain information is depends on the population. If we had other persons here that were smaller, the same way that we have several that are taller, then it wouldn't be that characteristic. And another thing that I want to discuss is how privacy evolves with technological progress. And there's a really interesting book about information technologies in general that has a chapter dedicated to privacy, which is this one depicted here. And he narrates how privacy evolved over time. Like, imagine at the beginning where we lived in small villages, they were reciprocal privacy breaches. Like, you knew if someone knew certain information about you, and in the same way and with the same ease, you could find similar information about them. But once the Industrial Revolution happened and we started to live in larger populations and cities, anonymity occurred, which wasn't a topic before, right? So then, besides being either alone or surrounded by people you know, you could also be surrounded by people you don't know and who don't know you. And this introduced a whole different variable. And a lot of people, when they talk about privacy and the good old days, they're referring to this kind of privacy, right? Because before that, there wasn't that kind of anonymity that a lot of people desire nowadays. And then much later, when the digital information and communication technologies started becoming more widespread, asymmetrical privacy breaches were possible, meaning that some people were able to find information about them without you knowing and without you consenting, potentially also using it against you in certain ways, right? And this is where privacy really started to kick off. And for example, now more recently, you can imagine, like, with technologies like these language models, it's even more easy to extract information from speakers. Like, you don't even need it to be structured in a certain way, like a database where you have age, name. You can extract all this information from natural language very easily nowadays. Yeah, and all this evolution requires also to view privacy in a different way, right? So the seminal paper on privacy that I mentioned at the beginning, they also highlighted this issue, because they mentioned that our thoughts, sentiments, and emotions should be private as well. And they differ from what property usually is, like our house and car, because this kind of information is part of our identity. And this ends up being, according to this book that I mentioned, leading to a view of privacy that is self-constitutive. And we also think, we also see it like that in certain ways already. For example, when you think about identity theft, when people steal your information online, you see that as them stealing your identity. So this is one way of breaching your privacy, which is stealing your information. But there is also a second way, which is someone giving you information you don't want, or assigning you information online that you don't want. You can imagine, like, for example, lying about some interests that you may have, or changing your height on your online dating profile. There's a lot of stuff that you can do in both directions, both stealing information from you and giving you information that you don't want. Yeah. And given all these recent advances in how easy it is to breach the privacy of people, European Union launched this GDPR, this new regulation for protecting the data of people. And its main aim is to protect sensitive information. And sensitive information can be of two different natures. Biometric information, which I assume you are already familiar with, like the fingerprint, your iris, voice prints, and so forth. And then also personal information, like your background, your health, religion, and so forth. And processing this information without the consent of the users is prohibited by this new regulation. Okay, and why is privacy important, right? Because seeing like how dangerous it is for people to have access to your information, you may think that, well, maybe it's best to not give them access at all. But actually, there are a lot of positive things that you can do with aggregated data from a society, right? I think COVID was a really good example of it, of how to analyze disease spread and the effectiveness of different countermeasures and so forth. And there are also examples in like economics on how to explore in a societal level how different measures and regulations benefit society. And this can only be done if we all contribute our own data to form like an aggregated data set that can be used for this kind of purposes. But of course, this has to be done in a way that it does not violate the privacy of each individual. Because as we've seen, their reputation can be damaged, there can be defamation done against them, and this information could also be exploited, like for example, for targeted advertisement and so forth. So how can you imagine such a privacy-preserving approach working? So you have some population where you're gathering data from. This data is then anonymized and aggregated, and then you have to assess in some way whether this data is properly anonymized or not. And the way you do that is whether individuals can be identified from it or not. And based on that evaluation, you can decide whether this data is suitable for being published or not. And there are different ways on evaluating privacy or designing privacy-preserving systems. A very simple one that is very good to highlight how this works is called k-anonymity. And here we have an example where k equals 3. And this means this data set is 3 anonymous because every subset of each person's data is the same as the data from at least 2 other people. And you can see, for example, here, the top 3 rows, you have the zip code and age and disease. They're all the same for these 3. But this is actually already the first flaw of this system, which they call the homogeneity attack, which basically says that because all 3 records share the same medical diagnosis, the attacker can infer that attribute for everyone in that group, right? So it doesn't matter if there's 3, if they all have the same data, you know that each of them has a heart disease. So this is already the first flaw in this kind of anonymization. And the second one is that you can use external knowledge to infringe also the K threshold. So for example, here you see the background knowledge the attacker may have about Carl. And with it, he already knows that the disease that Carl has is either heart disease or cancer. That's 2, not 3, as promised by the k-anonymity. Yeah. So there is a second approach to privacy, which is more robust, and it also addresses these 2 weaknesses that we saw for k-anonymity. And it's based on this principle cited by Dwork, which is one of the main contributors to this field, that says that overly accurate estimates of too many statistics compromises privacy. So what the differential privacy does to address this is injecting noise into statistics to limit what can be inferred about any individual in this data set. And the premise that they're trying to solve is like, imagine two data sets where the only difference between them is one person's data. Here in the image, it's called Joe. So any kind of analysis you do on this data, the result should be the same regardless of whether Joe is present in the data or not. Because if the result varies, that is already giving you information about Joe, which is exactly what you don't want. Yeah, and this noise, then the amount of noise you can introduce into the data, you can inject, is also a parameter that you can change to play around with the trade-off between the fidelity that you have to the original data and the privacy that you provide. But always, for it to be differentially private, you need to fulfill the requirement we just mentioned about Joe's information. Another very interesting aspect that Dwork covers in a talk that I will show you later is that anonymized data may be more telling than its original counterpart. And this might be a little bit counterintuitive at first, because anonymizing is some kind of blurring that you're doing, but you can also see it as removing outliers or removing peculiarities about the data that may tell you something about certain people. And this kind of blurring can make the analysis easier, and we will also see other examples of this throughout the lecture. And the last thing I want to say about privacy before moving on is to state again how ambiguous the topic of privacy is and how context dependent it is. Beckstrom, which is a professor that is also working on this topic for speech particularly, I remember seeing a survey talk about privacy that he did a couple of years ago, and he mentioned this example that I have here, which basically asks the question about how is privacy handled in a dialogue. So here I'm showing you a picture of a scared woman or girl which is interacting with someone. And does this tell you anything about the person it is interacting with if you see that this girl is being scared? And hopefully you can imagine like the other person is probably angry or scaring in a certain way. So by analyzing only the information about the little girl, we can infer information about the other person in this interaction. So this is a different way of looking at privacy, which is very interesting and thought-provoking. And yeah, in the lecture that I mentioned from Beckstrom, the survey talk, you can find the link here. I will share all these slides with you afterwards if you're interested in any of these topics. The second lecture here is about the GDPR, and the third one is about the differential privacy, and also mentioning this concept about anonymization. So yeah, so summary, publishing data is good, but it must be anonymized to not infringe the privacy of its individuals, as they can be exploited in many ways. And privacy, counterintuitively, it may even facilitate analysis. And finally, as we saw in this last example from Beckstrom, it really depends on the context, and you have to have a really holistic approach to privacy to really cover all the different weaknesses that you may have. Are there any questions? Okay. So the second part is we're going to move into speech now. Speech is a very rich source of information compared to text. And speech encodes both biometric information, like you can infer the age of someone, the gender, and also personal information like their cultural background, whether health conditions and how they're feeling, And most of these can be identified by computers in very laboratory-like settings for now, but accuracy is improving very rapidly. So we should go from the assumption that they will only get better with time, and like they are really able to do that. That's why the GDPR is so important to address this kind of dangers. And you can imagine here Jack Torrance, if you record him here checking on his wife in The Shining and you analyze his speech, it is really easy to infer that he's a male, that he's over 40 years old, American, and you may even infer that he's not mentally healthy. Yeah. And again, about this contrast between speech and text, there are several differences that lead to this difference between them. The first one being that speech is a physical phenomenon that has to be captured, right? So when we talk about speech, is whatever we capture through a microphone, whereas text is a much more abstract level of information, also much more information rich, because it doesn't have all the other stuff that we can find in an audio signal that comprises speech. Yeah, and speech being a signal also means that it's not discrete, which makes it easier to categorize, like what we're seeing before about this data sets where you see age and stuff. It's not so easy to read from speech. You can infer it, you have probability distributions around it, but it's just not that black and white. Yeah. And all of this makes it entangled, which means that like the same sentence may have a certain meaning, but it also carries some identity. And also emotions carry identity. Like the way that I express happiness is different from the way any of you may express it. So an important task in speaker anonymization, for example, is to be able to separate the two, separate the meaning from the identity. Yeah. And all of this makes speech processing more complex, but it's also much more rich in information. And if we're able to effectively process it, we can learn a lot more. Like, for example, detecting irony is easier in speech. And we humans are really good at gathering a lot of information from hear others talk. Yeah, machines are not there yet. They are, of course, also not as robust. Like, for example, if I utter the same utterance here or in a busy street, the speech signal is going to look completely different. For another human, that may not be challenging, but for these processing tools that we use, then it becomes much more challenging to see the same meaning on both scenarios. Okay, and then now going into anonymization. So the definition that we're here after is that speakers are anonymized when they cannot be identified from their speech. And for this, we need to look at all the different aspects of speech that may carry identity. So we talked about emotion before, which falls into this prosody category, which includes the rhythm, the intonation, like which words you accent, how fast you talk, and so forth. Then the voice or the timbre, which refers to the anatomical characteristics of our voice sounds, the voice print that we mentioned earlier in the as biometric information. And then also information related to your demographic and cultural background. Like, for example, I'm from Spain, and someone may identify that when hearing me speaking English. Yeah. And one thing that we are not considering here in speaker anonymization is the content. So what the exact words, the transcript of what is being said. That is something that is studied in a different field, which is called text anonymization. And the reason that we separate these two is just because they are processed in very different ways. Of course, an approach that focuses on both together will be more powerful, but the techniques used for each of them are different. Yeah, and I have here a video for you about how anonymization works, which is from a project where we do remote therapy in German, and we're trying to anonymize it.
Ich sage ganz einfach, Deutschland ist ein starkes Land und das Motiv, in dem wir an diese Dinge herangehen, muss sein, wir haben so vieles geschafft, wir schaffen das. Wir schaffen das, und wo etwas im Wege steht, muss es überwunden werden, muss daran gearbeitet werden, und der Bund wird alles in seiner Macht Stehende tun, zusammen mit den Ländern, zusammen mit den Kommunen, genau das durchzusetzen.
Yeah, sorry, it's a bit not that loud, but I don't have any speaker with me. But yeah, here you may see that it's a completely different use case from the ones we saw at the beginning, because here we are focusing on anonymize a single person, not a whole data set. But the same concept about privacy facilitating analysis still applies. And here, for example, some of you may have noticed who this is, but if not, if I told you that this was Angela Merkel, as is the case, this may change how your perception of the video, right? Because you know about her political inclinations, and you may understand what she's saying now in a different way, as if she was someone from the opposition, for example. So this shows you how anonymization in this case can help you be more objective and really focus more on the signal, leaving behind some preconceptions that you may have. Yeah, and we showed this on the long night of science with Brendan was there as well, presenting text anonymization stuff. And it was really interesting because people could talk with each other through this simulated video call that we were doing anonymized. And it was really interesting to see how they reacted to seeing and listening to people they know anonymized. And I encourage you to try out anonymizers. Like most of the systems that I'm showing you here today, you can find them online easily, and they have notebooks that you can run on your laptops and see how it works. And hopefully, after listening to this lecture, you can also see their weaknesses. We will talk about the system here a lot today. But other systems may have other weaknesses, and we will look at these characteristics today. Okay, so the first work that I know of that talks about speaker anonymization was done in 2009 by Jin and colleagues, and they studied several concepts that are still core intuitions in the field today, and we will look at them today. Yeah, and the first one is the close relationship between voice conversion and anonymization. The second one is how many speakers do you need for a reliable evaluation? Then the role of phone durations in speaker identity, and target speakers, how they affect the trade-off of privacy and utility. Yeah. And voice conversion and target speakers is a very important topic here. The meaning of voice conversion, this is another task within speech processing whose purpose is to convert one's voice to sound like that of another without changing the linguistic content. Like, for example, what I'm saying right now, but it's being said by Brendan with the same words and the same meaning, but without any of my identity remaining behind it. This is, of course, not always possible, but this is the goal of this field. So, and here within this definition, we already see there are two speakers involved. Me, I'm the source speaker here, and Brendan would be the target speaker. And for anonymization within a data set to make sense, target speakers have to be chosen randomly, right? Because if I tell you that I'm anonymizing my voice with Brendan's always, then anytime you hear Brendan's voice, you already know it's me, the one being anonymized. So you need some randomness in the selection process so that it cannot be linked back to the source speakers. Yeah, and another thing that we will discuss today, but it's still uncertain, is what is the relationship between sources and targets in their effect on utility and privacy. There's a lot of research going on, and I will show you some, if we have time, about this in the end. Then going back to the paper that I was mentioning, so their anonymization approach consisted of 4 steps, which is actually a way of anonymizing that has been repeated, like doing more steps to increase the anonymization. And they use a voice converter in steps 1 and 3. Step 2 consists of normalizing the durations of the phones. The phone is like a character in the alphabet, right? It's like the smallest unit in speech. And then the last step includes some interpolation, and the purpose of it is to keep pushing the anonymized speech further away from the original. And their evaluation approach is also very interesting because they address firstly the speaker identification and then an approach based on phonetics. So the second approach is basically that you extract the phone sequences, which is basically similar to the text, but with phones. And you can also measure the duration of each phone within an utterance. And you can use that to identify speakers. So in table 1, they show identification rates out of they used around 200 speakers. And here you see the phonetic speaker identification. They were able to effectively identify original speakers using this approach. And then the speaker identifier, we will go about this kind of approach later on, but it's just a system that is trained to identify speakers. And they were also able to identify speakers reliably with this system as well. And then table 2 shows the de-identification rate, so the percentages of times that they were not able to identify the speaker, and you see that they are all really high, so they're showing that their conversion approach worked really well. Yes?
If you talk about the phonetic-based identification, you're just interested in the speaker-specific varieties of the pronunciation and not really, because the phoneme relates to some graphemes and to what the speaker said.
Yep.
So you're not interested in the text-based
No.
identification. Just the phoneme characteristics that,
Yes.
for example, German cannot pronounce the TH properly in English, and then you would say the instead of the, and that will be a kind of indicator in order to guess the person.
Yeah, and also like mean durations of phones,
Yeah.
like to measure, for example, how fast you talk.
But
Or
not the linguistic content of
no,
the grapheme.
exactly.
Okay, good.
At least that should be the aim, right?
Yeah.
To ignore the linguistic content. Yes, that's important. Yeah. Okay, and so yeah, we've seen that. Well, I forgot to mention here, they also run a subjective evaluation to measure both the privacy but also the intelligibility, because this is very important for anonymization. Is that if you really like destroying a speech signal is perfectly anonymized, right? Because you cannot identify the speaker. But that is, of course, useless. That's why you need to measure the privacy against a utility. And in this case, they used intelligibility. Like they asked people, can you understand what this anonymized utterance says? And the trade-off between privacy and utility is a central aspect of speaker anonymization. Assuming that the consumer of this data doesn't want to find out the identity of the speakers, you can explore this trade-off. And then you have to ask like how much privacy is required. And on the other hand, what does the consumer really want? Because that is what defines the utility that you are trying to preserve. If it's transcripts, then you would go into intelligibility, or if there's like a multi-party conversation that you're recording, also distinctiveness is important. And for example, this is easier to anonymize because intelligibility, the transcript, is easier to disentangle from the speakers. The second utility mentioned here, emotions, is much harder, right? Because it's really hard to disentangle the meaning of the emotion and the particular way the speaker is expressing it. Yeah, and then there are, of course, other requirements that may be interesting, like multilingualism, if you are using this kind of systems in a scenario where multiple languages may occur. Yep. Yep.
If you go back to GDPR, basically the GDPR puts you a minimum threshold for privacy. It does not consider utility at all, right? Or does GDPR say something like provide any reasonable level of privacy given a certain level of utility you need to maintain in order to do something with the data?
Yes. Contrary to differential privacy or the more strict constraints that we were seeing at the beginning, there is really no ground truth for privacy evaluation, right? There is no real tangible way of measuring privacy in speech. That's why nowadays companies, they are just required to do their best effort, whatever that may be. But there isn't really any way of doing this.
Threshold on privacy here.
There is no such a set in stone constraint, unfortunately. Yeah. And yeah, after this GDPR was published, research in anonymization became much more popular because, of course, for the industry, it was also much more important. So there was a lot more money in this field. And then the Voice Privacy Initiative also started, which provided attackers to run this privacy evaluation, which is able to identify speakers both from their voice and prosody, as we will see. And they also provide a utility evaluation that we will see later. They do not include the accent, mostly because the data set that they're using is not diverse in that regard. But I wanted to mention this other evaluation framework called Voice PM, which runs an evaluation based on attributes. And these attributes serve as quasi-identifiers, meaning that you can identify speakers with a combination of these attributes. Like, for example, if you know the age and zip code of a certain person, you can already reduce the population size a lot. If it doesn't lead to identifying that person, it already reduces the amount of candidates by a lot, which makes then an objective evaluation easier with an informed attacker. Yeah. And another positive aspect of this kind of evaluation is that it is much more explainable. So you can really see which kind of attributes are being leaked and which not, which can give developers more ideas to improve their anonymizers. Yeah, but let's talk about how speech is being anonymized. So here I have the two main approaches. Voice conversion is the one that we saw before in the video. And the second one is provides perfect anonymization, which is transcribing the speech, which removes all the speaker information that is not included in the text, which recall we are ignoring here for this evaluation, and then synthesizing it again to get speech again. So yeah, hopefully you can hear it.
God, as a direct consequence of the sin which man thus punished, had given her a lovely child, whose place was on that same dishonored bosom to
God, as a direct consequence of the sin which man thus punished, had given her a lovely child, whose place was on that same dishonored bosom to
God, as a direct consequence of the sin which man thus punished, had given her a lovely child, whose place was on that same dishonored bosom.
Okay, so hopefully you have noticed that the prosody changes when you do STT-TTS. So the phone durations, the timbre and so forth in the voice conversion is really similar to the original. Whereas when transcribing the speech, you're losing all of that prosodic information, which leads to a much better anonymization, but also less utility. And this is exactly how the picture looks for these kind of two systems. So within the trade-off between utility and privacy, you have on one side, you have voice conversion, which offers really good utility because it preserves a lot of speaker information. But the privacy is not as good. This is why in speaker anonymization, we are trying to preserve this utility while improving the privacy. And on the other hand, you have the STT-TTS approach, which offers really good privacy but bad utility because you're losing all the speaker information through the transcript. And the goal here is to improve the utility by reintroducing some of that speaker information back again into the anonymized speech. So looking more in detail into this STT-TTS approach, so this is, of course, better suited for scenarios where privacy is paramount. And also, it is easier to combine with text anonymization approaches, which is also interesting for a lot of use cases. And as I said, for it to be improved for anonymization, you have to improve fidelity. And you could do that, for example, as depicted in the figure in the upper channel, by recognizing some attributes from the input speech, anonymizing them in any way, and then feeding them back into the anonymized speech. You could do that with emotion, and you could do that with other kinds of information as well. An example of this, of such a pipeline, is from Meyer et al., where they improve the fidelity of an STT-TTS system for prosody cloning. And they use duration, pitch, and energy, which they feed back into the anonymized speech. And interestingly, they ran this in an older evaluation from the one that we have now, and they didn't need to anonymize this prosodic information to retain the perfect privacy that they achieved with STT-TTS. But now with the newer evaluation, and we will look at the differences between them later, there is a decrease in privacy, meaning that the new evaluation framework is able to exploit the prosodic aspects from the to identify speakers. Yeah. Okay, and now for voice conversion. So as we already saw, voice conversion is a speech-to-speech approach for converting a speech sample so that it sounds like it was uttered by someone else. And this is better suited for applications with less privacy constraints because they offer better utility. Applications like those requiring human interaction really benefit from preserving prosody better. They also sound more natural. And these kind of approaches are also more efficient because you're not going through text first and then again to speech. Yeah, but as we said, the privacy of them is not really well. So also here in the upper part, you can see you can include anonymizers for the different features that you may be extracting from the signal. And then you're also using some kind of target speaker for producing the anonymized speech in the end. An example of this system is, for example, the one from Champion et al., which improve the privacy of a voice converter in two ways. They have some content representation, which is also phonetically based, and they quantize it to remove speaker information. And then secondly, they also extract the pitch from the signal, but anonymize it by adding some noise to it. And in this way, they can also effectively improve the system's privacy. Okay, so to summarize this section, speech is more complex than text. It's a physical phenomenon, including a lot more information than what is being said, which is an opportunity, but it's also a challenge because it just makes it harder to process. And it requires a different approach to privacy because it's not as black and white, which also, going back to what Sebastian said about whether the GDPR had a certain threshold for privacy. Yeah, and there are two approaches of anonymizing privacy, each with their own characteristics and each suited for different applications. And we're always exploring this trade-off between privacy and utility, resulting in different approaches being better suited for different applications. Any questions? Okay. So the third part is privacy evaluation. So how can speakers be identified in general? There is a different field of speech processing which focuses on identifying speakers in general. Like, for example, you can think of these systems that identify speakers, for example, to let you in a building through your voice. So there's already a lot of research going on in identifying speakers that are not being anonymized. And there are basically two paradigms that you can explore here. The first one is called identification, which uses a closed set scenario, meaning that you have 100 speakers and your job is to identify one of those 100 speakers. You're not going to encounter a speaker outside of those 100. And then the verification proposes a more open scenario, meaning that you're given two utterances and your job is to find out whether they belong to the same speaker or not. Sorry. So you can have any two utterances, and you have to see whether they belong to the same speaker or not. Could be the same speaker, could be not. It's different speakers than the ones you see in your training. So you need to be much more robust. And for example, if you go back to the evaluation that we saw from Jean and their colleagues in the original speaker anonymization paper, they were doing identification. They were doing this identification rates. But the approach that for example, the voice privacy challenge uses, which is much more robust, much more comprehensive, uses both identification and verification. Identification is used for training because there is really no other way. So you have a training set with a certain amount of speakers, and you train a speaker recognizer to identify them. But this speaker recognizer is giving you some kind of representation. It's a vector that represents these speakers. And then these speakers generalize really well and can be used outside of their training scenario. They can be used for other speakers that you have not seen during training. So this is what we do in the evaluation. So the evaluation consists of two sets of utterances, the trial utterances and the enrollment utterances. The speakers that you're evaluating are present in both sets, and the trial utterances are the ones that you are trying to identify. Imagine an attacker which has certain utterances called the enrollment utterances, which the attackers can use to identify the trial utterances, which are their objective. They are trying to identify the speakers behind the trial utterances. Doing verification is better in certain ways because it's a more robust approach. It requires the model to generalize instead of exploiting the weaknesses of the data that it may find during training. Yeah. And then the second aspect is you need a metric to perform this evaluation, right? So you have pairs of trial and enrollment utterances, and the first thing you do is get a score with this recognizer, and you're comparing the vectors with cosine similarity to get a score, and you can plot these scores as I do here in this figure. Those that pairs of utterances that belong to the same speaker are here depicted as a blue distribution of their scores, and the orange ones are the ones that belong to different speakers. So now we have two distributions that we see that they're different in a certain way, but we need to draw a threshold to make decisions. So for example, what Jin was doing with identification, she was doing accuracy, measuring if I'm identifying, if the score that I'm giving the actual speaker is the best, then it serves as identified, and if not, not. But we cannot do that here because we are in an open scenario where the number of speakers is not really set, so we cannot rank the speakers. That's why we need to set a threshold. Yeah, and the way of doing it depends on the use case, because you're playing around with false positives and false negatives. So a false positive is when the evaluation says, so the attacker says that the two utterances belong to the same speaker when it's not the case, and a false negative is the other way around. The attacker says the utterances do not belong to the same speaker when they actually do. What to do depends on the use case. So for example, COVID tests are skewed towards false positives because it's just safer for someone to think they have COVID when they don't than the other scenario where they do have COVID, but the test says they don't, and then just they leave and contaminate other people. So minimizing false positives is a more secure approach. And on the other hand, minimizing false negatives is more convenient. It enhances user experience. You can think, for example, fingerprint on your iPhones or Android phones or your face recognition. Allowing for more false positives, thereby minimizing false negatives, is just better. It will lead to less inconveniences for the users. But what we do for this evaluation is to strike the middle ground between them, which is what's called the equal error rate, which is the rate at which both these kinds of errors are equal. And this makes it more fair because it doesn't allow you to to bias your system towards any of these kinds of errors.
You should be careful that here that we're talking about anonymization, and the higher equal error rate, the better. And for what we did in the past, like identifying speakers, the lower the equal error rate, the better.
Yes, good point.
Different concept.
Exactly. So a system that offers perfect anonymization would achieve an equal error rate of 50%, because we are here in a scenario where the attacker is making binary decisions, whether the utterances belong to the same speaker or not. That's a binary decision. So if the error rate is of 50%, this means that the attacker is making random decisions. It's not finding any kind of information to really identify any speakers. And yeah, Sebastian said 0% is the worst case from the perspective of the anonymizer, but it's the best case from the perspective of the evaluation, right? We want to have strong evaluations. And as an evaluator, I want to push the error rates down. And as an anonymizer or developer of anonymization systems, I want to push the error rate up. Yeah, and looking back at the two systems that we heard before, so the voice conversion one has a very low equal error rate, meaning that the attacker is effectively identifying a lot of speakers. And the speech-to-text system achieves a very high equal error rate, close to 50%. If it's not exactly 50%, it may be because the data set is not large enough to really approach the limit of this distribution. It may also be some inconsistencies in the evaluation. It's really hard to tell. Yeah, and finally, I just want to touch upon the other kind of evaluation that you may do, which we also saw Jin doing, which is subjective evaluation, basically asking people preparing a study and inviting participants to listen to this audio and asking them for their opinion, both in terms of utility and privacy. And focusing on privacy here, objective evaluation performs better usually, but it's unclear whether the comparison is really fair, right? Because we saw that the attacker, the objective attacker, is being trained. They're actually being trained with hundreds of hours of anonymized data, whereas in subjective evaluations, we're often just giving two samples to a person, one anonymized, one not, and asking them whether they belong to the same speaker without any kind of background information. And we ran a study with different participants with different degrees of information, and we saw that they are really able to identify a lot of the speakers with the system, the voice conversion system that we just saw. This is here in the table of the right. You see that experts, which are therapists, they are able to identify the speakers in 75% of occasions, whereas amateurs in 43% of occasions. But in both of these scenarios, where they all had some kind of background information, and the number of speakers was only 4, which is, of course, very much easier for them than to identify speakers. This paints a very different picture from the evaluation that, for example, the authors of the voice converter ran, where they reported a subjective evaluation with a very high degree of target similarity. So it really depends on how you train the participants and what kind of information they have, their expertise, and their level of perceptiveness about speakers in general may affect these results. And another important aspect about subjective evaluation is that they characterize anonymization better, because if I ask a participant, why could you be able to identify a speaker, they can really explain their decision to me. And we did this in this study with the 4 aspects that I mentioned before: voice, accent, prosody, and content. And they were telling me which are the weaknesses of the system, which is very important for me as a developer to improve them, right? Whereas in the objective evaluation, I cannot really tell what is going on. I can only see this number, this equal error rate, but this does not really help me improve the system further. Yeah, so the first thing is, in general, like, we can only anonymize as good as we evaluate, which is something that we saw with the example for an STT-TTS system, where the new evaluation gave us the opportunity to run ablation studies and so forth, because previously the evaluation was saturated. Even if you reintroduced prosodic information back, the equal error rate was still 50%, so you weren't really able to tell anything about it. So it's really important to work on both sides of the equation, both on the anonymization and the evaluation. Yeah. And the objective evaluation that we're working on right now comes from this field of speaker identification, which apparently you've seen already. But they are trained on anonymized speech. And lastly, subjective evaluation is interesting for privacy reasons, utility reasons, and we will see more about it later, but most importantly, it can really let you know more about the anonymization approach. Any questions? Okay. Next, we have the utility evaluation. So we already talked about this trade-off between privacy and utility, and it is important for us to measure both. And this, the privacy challenge, they provided both, right? They provided an attacker to evaluate the privacy of the system and also utility evaluations. And in the first editions of their challenge, they focused on downstream applications, mainly, can I train a speech recognizer with this anonymized speech, and can it still understand? And they were also focusing on multi-party conversations, which requires us to always anonymize one speaker with one voice, and that voice has to be different from the others for the speakers to be distinct and the conversation to really to make sense for us. Yeah, and from the last, the 2022 evaluation, Panariello and colleagues performed a really great analysis of the results and also the status of the evaluation, and looking at these different factors. And for example, for the intelligibility, which is basically you take a speech recognizer, you train it with anonymized speech, and then measure its performance on understanding this anonymized speech, meaning the text, right? Whether it can extract the text, the transcript from the anonymized speech. And they showed, for example, that some systems were able to outperform the baseline, which is the performance achieved for original speech. You could say that this is because the anonymized speech cleans the noise or makes it less challenging. But in the scenario that we're using here, the data set that we're using, this is really not the case. So what is more likely is that the system is, the speech organizer is really to learn during training some mispronunciations and still correctly transcribing the anonymized speech, although it is not being intelligible enough. And this is also apparent in the subjective evaluation, which I will show later. Yeah, and voice distinctiveness, we've already said what it means, basically that you can still perform a multi-party conversation. And this leads to a weaker privacy evaluation, which we will also see later, basically because anonymizing always one speaker with another allows you, for example, to exploit weak links, right? You're evaluating 10 utterances of mine, which are always anonymized with the same target. And if you only are able to identify one of them, you can already extrapolate that decision to my other 9 utterances because of this one-to-one mapping between source and target speakers. And also it allows the speaker recognizer during training to really look at distributions of speakers more precisely. Yeah, pitch correlation, the aim here was to preserve the fidelity of the input speech. But Panariello shows with a simple experiment that it is really easy to obtain high values in this evaluation with a very little effort. So the utility of this metric is not that clear. And then in the subjective evaluation, they showed that there are huge disparities between the subjective and the evaluation results. So they ran intelligibility, for example, and the systems that scored very high intelligibility in the objective evaluation were not as good in the subjective evaluation. So there is very little correlation between both, highlighting the need of still running both kinds of evaluation. Yeah. And we've also worked on our own framework, which implements the same privacy evaluation, but uses also different data sets. Some of them, for example, like EDAC, which is one I personally like a lot because it is spontaneous speech. And spontaneous speech is much more diverse in terms of prosody and also much closer to what you might expect in a real-world application. When you're reading, the way in which you read speech is much different. And there's been many issues with this kind with these differences in a lot of evaluations. Yeah, and we also propose to look at emotion preservation as a way of measuring prosody. And for this, we also included an emotional data set. And all the utility evaluation happens with pre-trained models, because what we're interested in here is to evaluate whether the anonymized speech is well suited for human consumption. And we are not trained to understand anonymized speech, right? We expect anonymized speech to be intelligible from the get-go. And this is why I think we should also do the same with the utility evaluation. And for intelligibility, for example, you all may know Whisper, this model from OpenAI. It works really well. If you give anonymized speech to Whisper and also nowadays other speech recognizers, they all work really well. And there are similar systems for emotion preservation, and we also measure naturalness, which is a topic that WAFA works in. And they are all able to some extent, evaluate anonymized speech. Some are better than others, but they will only get better with time. And I don't see any other way of really approaching this focus on human consumption. Yeah, and lastly, we also focus on performance because, for example, in the use case that I was showing before about the remote therapy, we want to do this as real time as possible, right? And some approaches are just too slow for that, even if they're powerful. Yeah. So the privacy evaluation for the latest voice privacy challenge also includes emotion preservation. So you have here on the left side, you have the trade-off between privacy and intelligibility. And on the right side, you have the trade-off between privacy and emotion preservation. And you can see how different systems work better than others, but also the trade-off that increasing privacy also inevitably comes at the cost of some utility. And here they also made an improvement on the privacy evaluation, where speakers were not necessarily always identified with and were not always anonymized with the same target. And this increased the performance of the evaluation substantially. Yeah, and there's a bunch of evaluation frameworks nowadays, which reminds me of this sketch that you may know. Which is basically says that it's basically criticizing our desire to always propose our own solution instead of resigning ourselves to the solutions of others, which is definitely true in research and in engineering in general. But in this scenario, I don't think it really makes sense because different evaluations will push us towards different research directions for anonymization, right? So if you're only trying to optimize for intelligibility, then STT-TTS is perfect for you. You don't need to focus on prosody. Then you don't need to evaluate it. And then, for example, we saw about voice PM on the attribute evaluation side. Like, it also has strengths and weaknesses. And I think, in general, like researchers always overly focus on beating benchmarks. So it makes sense to have a variety of benchmarks, which will hopefully also lead to more robust anonymization approaches. Yeah. So how to anonymize speech depends on the use case. And each anonymizer, as well as each evaluation approach, have their different weaknesses. And ideally, they should be evaluated independently, right? These challenges are great for comparing systems, but in practice, an attacker is not going to use an overall approach to exploit your anonymized speech. They're really going to go into your weaknesses, and that's why it's important to try to evaluate them as well. Yeah, and what I just said about researchers and benchmarks, variety in this scenario is really good. Any questions?
Can you say what subjective evaluation is again? Like, what is that?
Yeah. So objective evaluation is that you use an algorithm, and subjective evaluation is that you prepare a study and invite participants, so human evaluation basically. Yeah. Okay. Then I will lastly talk about this last point briefly, which is a popular topic recently. As we said, the last privacy evaluation seems to use prosody, and that's why we can now try to anonymize it. So what is prosody? We saw timbre, which is like the anatomical characteristics of your voice, of your vocal tract, like how your voice sounds. And then prosody is the variation of melody and rhythm, which comprises both meaning and identity. Timbre is only meaning, right? Timbre is only identity. There is no meaning in your particular voice. But prosody, on the other hand, comprises both meaning and identity, which are entangled. Meaning that we all speak in different ways, different velocities. We accentuate different words depending on our background, how we're feeling, and so forth. But there's also a certain meaning, and that's where this example here shows. The blue lines are pitch contours, which you can also think about like the tune of an utterance, similar to what is talked about in music. And here you see like how the pitch changes depending on whether you're asking a question or not. And this is important information. So if you say, you know what I mean, you're ending the sentence on a low, which means you're making a statement. And if you say, you know what I mean, if you raise your voice at the end, you're asking a question. Yeah. And it has been empirically shown that you can identify speakers only from these kinds of pitch contours, which shows that they do not only encode meaning, but they also encode identity. The way that I raise my voice when asking a question is different than the way any of you may do it. Yeah, and this is a very interesting experiment where they train a prosody recognizer, which is, they train it purposefully with converted speech to be different from the timbre recognizer, so that they can really see how each of them are able to recognize speech. And the left figure here, you see the performance of ICAPA on the left, which is this speaker recognizer, the one that we were seeing before from the voice privacy evaluation. Beside it is the speaker recognizer, which is another one, also very good. Next is the prosody recognizer, which achieves an equal error rate of 10, which is similar to the one of the voice conversion we were seeing before, which is pretty low, right? Not as low, which the other one is like 1%, meaning that you can identify almost every speaker. And then at the rightmost bar here in the left figure, you see the timbre recognizer, which is also extremely effective to identify original speakers, which makes sense again, right? But then the most interesting figure is the one on the right, where they are analyzing identification performance on converted speech. And then an ICAPA, so the speaker recognizer trained on original speech, will not be able to identify anonymized speakers, obviously, because it's just not what it's trained of. But here you see that with the prosody embedding, you are really not losing much performance from converting the speech. Like you're going from 11% equal error rate to 14, which is a very low degradation, showing that converted speech does not convert prosody. Yeah. And there was a different paper that was looking at phone duration specifically, which we also saw Jin do. But in this work, they propose a formula to compare the mean phone durations of two different utterances. And if you look here at the results, which are also equal error rates, so you see for the original speech, 3.8%, very low. You're able to identify speakers from mean phone durations. Voice conversion, which preserves phone durations mostly, also very low, 7%. And then on STT-TTS, which you would expect to be much higher, 27%. This actually should be higher. The authors say this may be because the data set is red speech, which makes the diversity of prosody less. It could also be that some content information is leaking into the mean phone durations, right? Because the data set used here is like audiobooks. And for example, in one of them, you may use more for certain phones more than others, or repeat certain words more than others, which push your statistics in a different way. I think that's a more plausible explanation. Yes?
What you could also do is, you can usually trigger TTS systems in order to generate a certain type of prosody. So when you have basically recognized the speech with the speech to text, you could not necessarily go to the grapheme level, but also to a phoneme level with the phone durations, and then obfuscate the phone durations in a targeted way.
Mm-hmm.
So basically, you could try to increase that number by not just relying on whatever the TTS system does with the grapheme chain, but you could try to work on that in order to make it more anonymized.
Yes, definitely. But I think like here, the last number, like there is STT-TTS, right? You're transcribing the original speech and synthesizing. So within the text, there is no information about phone durations, which is what's being exploited here.
Probably the TTS system has a strategy in order to generate a prosody from the text.
Exactly.
And that might be perhaps similar to what the...
It might have also been trained on similar
and if you
text.
know what the original speaker did, you could basically try to
Yeah.
anonymize that.
Certainly, definitely, yeah. But the point here is that these voice conversion systems that we often use for anonymization, they encode, they preserve these phone durations, which can be used to identify speakers. And this is what I've been working on also lately, like to answer the question, like to what extent is the evaluation that we have nowadays is exploiting both phone durations and also expressiveness, which you can see related to the pitch contours that we were seeing before. And to this end, I proposed an evaluation approach which is interpretable and allows us to anonymize both of these factors to different extents. Yes, and here are the results. Similar, same also voice privacy challenge 24, privacy against intelligibility, and privacy against emotion preservation on the right. And you can see that evaluating any of these two factors leads to better privacy, but degrades utility. And you can also combine the anonymization of these two factors for an improved privacy. Yeah. So what this shows is that the evaluation is using expressiveness and is using also phone durations to identify speakers, or is able to do that if it makes sense. So that we need to anonymize that in our systems. And I also wanted to show you some samples so that you can see what I'm talking about. And this is also a Libri speech example, which is the one that we were using for all these evaluations. It's audiobook, so you can also get a feel for it. So this is the original speech.
Also a popular contrivance whereby lovemaking may be suspended but not stopped during the picnic season.
Okay, and then if you constrain the expressiveness a lot.
Also a popular contrivance whereby lovemaking may be suspended but not stopped during the picnic season.
So you can hear that it's much more robotic, much more flat. And this is, of course, harder to listen to, but also more private. And then the second kind of anonymization that we propose, which is anonymizing the phone durations.
Also a popular contrivance whereby lovemaking may be suspended but not stopped during the picnic season.
So here the expressiveness is preserved, but we are changing the phone durations. And this leads to weaker anonymization than anonymizing expressiveness, but certainly improves privacy according to the evaluation. And then you can also combine the two in different ways, but this is like a good middle point.
Also a popular contrivance whereby lovemaking may be suspended but not stopped during the picnic season.
Yep. Okay. Yeah, and lastly, the last thing, we talked about targets at the beginning, that this seminal work on anonymization, they mentioned in their paper that, yeah, maybe choosing targets better could lead to better utility, better privacy. And there's been a lot of work on this field. It makes sense for utility to some extent. You can also imagine like some application use cases where preserving gender or age makes sense for the consumers of the anonymized speech to really understand better what is going on. But what we don't expect is the targets to affect the privacy. And we show here that this is the case. So like for a certain configuration or a strong one with respect to privacy of the system, changing the target selection algorithm for completely random to considering gender, to preserving gender, delivers completely different results. And also in the way we don't expect it to, right? Because if you do same gender selection, you're already telling the attacker the gender of the source speaker, because it's going to be the same as the one from the target speaker. But here we see that the attacker is not really able to cope with the same gender selection really well. So this means that it has some sensitivity to targets that we need to improve from the valuation side to make it more robust to targets, and that's what I'm working on right now. Yeah. So to wrap up, we see that prosody comprises meaning and identity, in contrast to timber, which only comprises identity, and that they are hard to disentangle. We've also seen that speakers can be effectively identified from pitch and phone durations only, meaning that as anonymizers, as developers of anonymization, we should anonymize these two aspects. And we've also shown that not only you can identify them when targeting them specifically, but also that the current evaluation approach also is able to leverage these prosodic characteristics to identify speakers. Thank you.